All right, so here we go, pre-calc guys. It says it right up top here. It says we're going to be solving trigonometric equations, and we're going to use our identities soon. But I want to show you that these trigonometric equations are super simple, and you can treat them like you treat any other algebraic equation, and solve them the same type of way, assuming that sine x is just like a variable, okay? And don't think of it as this I say daunting task of hey, what do I do now? I can't find any values for these. I can just relax, breathe a little bit, and then you can solve these normally. There's going to be a lot of factoring going on, as you see with these two things. You can factor out pieces, okay? And then you can, factor using the anti-FOIL method is what I call it, but it's still just factoring. What you're going to see here is a difference of squares. So let's just get started. I don't want to, just keep talking all the time. I know you've hopefully sped this up to 1.5 speed so that you are not sitting here for 20 minutes, because it's going to be a long video. We've got a lot of these to do, and I want to get you used to solving these equations. So the first thing is, what do I see that they have in common? And I'm going to factor out 1 sine x. Okay, and so I take a sine x, and then what's going to be left inside is sine squared x minus 4. And that's going to be equal to 0. And if you look here, this is a difference of squares, and this is just sine x. So when we solve this, it's going to be a little bit easier. So we have sine x, and then we're going to factor this one, and then we're going to have 3 different solutions for this particular equation. So sine squared x, is sine x times sine x. And then square root of 4 is 2. And because this is a subtraction sign and it's a difference of squares, one is positive, one is negative. And now we're set. Now we can set all 3 of these equal to 0. So we're going to say that sine x equals 0. And we can talk all about this. Well, this is where is the y value 0. And we're going to say, well, the y value is 0 at 0, so, oh my gosh, what did I forget? You guys didn't tell me. Now, to get rid of the sign and just solve for x, because we want to solve for x, we're going to say, we're going to multiply by the inverse sign. Nuts. We're going to multiply by the inverse sign, and that gets rid of the sign. So inverse sign x. Oops, put it in the wrong spot. Let's try that again. Times inverse sine x negative 1x. Same thing over here, but that that goes away. So x is equal to pi and 0, right? Or 2 pi if you want to put 2 pi there. And I'm only going to solve these for one revolution around the circle. I'm not going to solve for multiples, but you could always add to those, plus 2 pi n to show that every revolution you're going to hit this mark. I'm going to go ahead and solve this one right underneath, and I'm going to say that the sine of x equals -2. Now, is there ever a spot on that unit circle where the sine of x equals -2? And we're going to say, no, sir, that doesn't happen, right? And the same holds true with the sine of x equaling 2. Well, where does the sine, is there ever a spot on the unit circle where the sine equals 2? And we're going to say, no, sir, that doesn't happen. So the only solutions, the only real solutions for this are the multiples of pi and 0 or 2 pi. Moving on, we're going to move to this next one. Again, we're going to factor, and we're actually going to find, hopefully, find some value where we get a 0. And we're going to see it's not that difficult. I want to move this. Nah, I'll get rid of that. All right, so I'll just shift over a little bit. Pardon me. What do sine times cosine x minus 3 cosine x, what do they have in common? We're going to factor out a cosine x, and then what else do we have? We have sine x, I do that all the time now, apparently, is -3, and that's equal to 0, right? And this one, just like the other one, we'll solve the first. We'll solve cosine of x equals 0. Well, where is the x value 0? And that would be at, well, of course, we multiply by the inverse cosine to get rid of this, and then x would equal 0. Okay, well, where is it 0? Sorry about that. I should write it like this. I apologize, I didn't write the last one like this. Inverse cosine times 0. Because when you put this in the calculator, you're going to see that the inverse cosine of 0 is, what is that, pi over 2, and 3 pi over 2, right? That's where there's no x value, or 0 for an x value. Oh my god, I said 0, and I meant, while I was trying to write a 2, look at me, having a big day. Okay, you're also going to see that we have one that doesn't exist, right? So if we try and solve sine x minus 3 equals 0, then sine x equals 3. Well, we see that, the sign is never 3 on that unit circle. So this doesn't exist. Right, so sometimes you're going to run into these problems where you're factoring out and only part of it works out. Right? So that's good. I hope that's good for you guys. Let me get rid of this stuff, and we'll move on to a couple more problems. These should be a little bit easier to solve, only because I can, 1, use a trig identity, and 2, take the square root of both sides, and I should be able to find a value. The funny thing about this one is tangent squared. I got to move somewhere where I can actually write on the page. So we take a look here, and it says tangent squared equals 1. So if I take the square root of both sides, I'll write it out. Tan squared x equals 1. I then take the square root of both sides, and I get the tangent of x is equal to positive or negative 1. All right, so there are quite a few values on the unit circle all the way around where the tangent, which is the sine over the cosine, is equal to 1. And remember, that's at 45 degrees, right? Pi over 2 over pi over 2, or any version thereof. So if we take the inverse tangent on both sides, we would see that x equals inverse tan of plus or minus 1. Right? And if you plug that into the calculator, you would get a couple of different values, but here they are in blue. All right, so x is going to equal, well, pi over 4, 3 pi over 4, because that's a negative version, isn't it? Let's see, 5 pi over 4. That's a positive version. And then there's the other negative version, which is 7 pi over 4. And if they ask you for all solutions, you would just add a plus 2 pi n to each one of these. But that's where this exists on the unit circle 1 revolution. All right, so here I'm going to use a trigonometric identity. I'm going to use a Pythagorean identity. I need to know how to convert cosine squared into something that looks like sine, so I can do some mathematics with it. And here's what it looks like. We know that sine squared plus cosine squared equals 1. Therefore, cosine squared equals 1 minus sine squared. Right? We've done this in class. I'm not going to keep going over those identities. I just want you to remember that 1 minus sine squared is the same thing as cosine. So I've just substituted for this with this. Okay? And then I'm going to keep this here. Sine x plus 1. All right. So now I have something that I can go ahead and factor. Whee! I put my ones together and I get 2. And I also have negative sine squared x plus sine x plus 2. All right. Well, I don't like this negative 6 1/2 dozen of another. If I multiply both sides by negative 1, I can change these signs. Or you can just factor it out using the negative 1 positive. But this looks better for you guys, fits better in your head, so let's go ahead and factor. I want the negative by the 2, I want the positive by the 1, and sine times sine. Boy, we're running into a lot of does not exist. If you look ahead, oh, that's not a squared. That's just sine x, isn't it? Geez, Sokol, making all your mistakes today. my humanity is showing. So we're going to solve both of these. We're going to solve sine x plus 1 equals 0. And we're also going to solve, let's use a different color. I don't know if that'll even show up here. There we go. We're going to use sine x minus 2 equals 0. And we see that this won't exist. Equals 2, positive 2. And we see that that doesn't exist. So let's go ahead and finish this one out. We subtract from both sides. Where does the sine of x equal -1? And we multiply by inverse sine and inverse sine. And so x equals inverse sine of x -1. So where is it -1? Where is the y value -1? And there is only one solution if you're talking about one simple revolution around the unit circle. And therefore, that solution would be 3 pi over 2. All right. And so I'm going to pause this. I'm going to go ahead and solve the rest of them in another video. I don't want the video to run too long, so I'll be back with other solutions.